This conference will now be recorded.
Good morning, students. Wait for a few minutes. Some of the students have to be joined here. Okay, students, we will start the class. What we discussed in extra class, that is the principle of electromechanical energy conversion, and we discussed about what are the different devices will involve in the energy conversion. So there are three categories which are using in the electromechanical energy conversion. One is transducers. So transducers is converting from light to electrical source. And next one is relays, actuators. That is second category. On third category is where we require the continuous energy conversion. That belongs to the third category. And examples are motors and generators. And we discussed about energy balance equation. So what is the balance equation means? If you are giving that electrical energy as an input, and the output is you will get mechanical energy with some losses in the sense in the form of magnetic field, right? So these are the topics we discussed in yesterday's. And one more thing, this type of principal energy conversion is depends on the law of conservation of energy. So so these are the topics we discussed in yesterday's class. Now we are going to discuss what are the different types of magnetic system. So magnetic system in the sense, suppose if we are giving that single excited system, what will happen? Double excited system, what will happen? Let me derive in today's class. And so in first unit, especially triple E students, in first unit you have two parts. Part one is it is completely belongs to that magnetic materials. So what we discussed before yesterday, up to that is stack of magnetic materials and magnetic field force, AC operation. So these are the part A. Now part B is principle of electromechanical conversion. In that, this today what we are going to discuss, the topic, the derivation is very important for your external exam. So this is completely derivation part. Just keep the note on that all equations. Then only you can understand that how the derivations will proceed. Right? Let me start that class now. So today topic we are going to discuss about types of magnetic system. And magnetic system in the sense, if you are based on the excitation, how the field will be generating. So that's what we are going to know in this topic. Now, generally, if you consider any magnetic material, so I will show, you can see here, this is the magnetic material, and on magnetic material we are placing one coil, and when we are energizing this coil with respect to the current, due to the current, the magnetic material will use the magnetic field, but which these are not in uniform. So uniform in the sense it is not in non-linear. Why? Because we already seen that BH curve, right? So if you seen in the BH curve, the characteristic should not linear. So linear is both are proportionally variation. But in the case of this magnetic system, we are not getting the linear characteristics, and this field should be magnetized, that is attracted or repelled based on the what we are giving that. So suppose if we are giving that supply by using plus minus, then it should be attracting field. At the same time, if you are giving, if we interchange the terminals, then it should be ripple based. And here, when we are applying that source, the energy should be stored or retrieved. Stored in the sense, some of the field will be stored, or retrieved means it should be evaporated, like expanded from one place to like this. So this is the magnet, how the magnetization will be happening in the magnet system due to that current flow through this. Now we'll see that different types of magnetic system. Right. So depending on the number of excitations. So what is meant by excitation? So excitation actually, you may get 2 marks about define excitation coil. So excitation coil is nothing but a coil should carry the current that is called as excitation current. Excitation means the particular material should be excited by the current. So current is excitation parameter. So that is called as excitation coil, and it depends on the number of excitations we are using in a magnetic system. These are classified into two types. One is single excited system and double excited system. So single and double means we are placing that sources among the different parts. If we are using entire device only one excited system, then it is called as single excited system. If we are using two multiple, that is more than one, then it is called as double excited system. Let me see that what are the examples for single excited as well as double excited. Right. See, I have seen this diagram here. This is the attracted armature type. So this is like a relay. Now here it has that two coils. This is fixed coil and it is a moving coil, and this also called as armature. So armature in a sense, it should be moving like this, right? And in this part, the remaining supply is connected to the home appliances. See, when the energy is given to this coil, so here we are placing the n number of coils on the magnetic core. When we are applying the source here, this coil carries the current. Due to the current, this core will be energized and it will produce the flux. When the flux is produced in this coil, in this core, then it acts as a magnetic system. Then it should be attracted here. It should be attacked like this. Then the continuous supply will be coming. Now, when the current is zero, then it should be de-energized, and this armature will becomes open circuited. So this is called as solenoid armature type. So or attracted armature. This type of construction is called as attracted armature type relay. Now we will see that what are the different types of devices which is belongs to the single excited system. The first one is electromagnetic relay. What we are using in our home appliances, that is MCB, manufactured circuit breaker, right? And next one is reluctance motor, hysteresis motor, solenoid coil. So hysteresis motor we can use in that printing machines. So small printing machines we can use the hysteresis motor. And reluctance motor we can use in the where the coins there is a something where the names are indenting on the metals, right? So there we can use the reluctance motor. And this figure shows that attracted armature type relay, and which is an example of example for single excited system. Now we are going to derive the equation based on this construction. So based on construction means generally in this electromechanical energy conversion we can write that energy balance equation. So we are giving that electrical energy, this is input, and we are getting the magnetic and mechanical energy plus some field. So this is the energy balance equation. So we are applying the electrical energy. After that, magnetic field will be generated. After mechanical force will be delivered. So this is the energy balance equation. Now we are going to derive the derivations about this single axis system in the form of these three parameters: electrical energy, that is input energy, mechanical force, and field energy stored. So these three parameters we are going to study in this. And keep remember that I will ask the question. So which one is example for a single excited system? So in the given and the options, solenoid type, attached armature type, synchronous machine. So I will give. So you had to choose the correct answer. So the single excited system is example is attracted armature type, solenoid type, hysteresis motor, and reluctance motor. Next. So these are the single excited, and when we call as multiple excited means when the device should need the double excitation, then it is called as multiple excitation system. And we'll see that what are the examples for multiple, that is double excited system. One is synchronous motor, alternators, DC shunt machines, load speakers. So why means if you consider that DC shunt machine, it has the two parts. One is stator and rotor. Stator is called as field and rotor is called as armature. Keep remember this. So in a DC shunt machine, it has the two parts. One is stator and rotor. Stator is consists of a field winding and rotor is consists of a armature winding. So both carries that different magnetic field. So it has the two winding side. That's why it is called as double excited system. And similarly, synchronous machines also, it has the two parts. One is stationary and rotationary. Here we are giving the AC supply to the stator and DC supply to the rotor. So that's why this machine is energized by the two types of supply. That's why it is called, it belongs to that double excited system. And we will see the load speakers. So when observe the load speakers, it has the two connections. One is from direct from supply, another one is from amplifier. So amplifier supply is giving to the energy to the speakers, and amplifier is gives the purity of the voice signal. So that's why loudspeaker has the belongs to that double excited system. Now we'll see that how the double excited system is look like. Right. So just now I told you that there are different types of example for double axis system, that is synchronous machine, DC shunt motor, loudspeakers, same thing. So let's consider this a synchronous machine. Here the outer, this part is called as stator and this part is called as rotor. Now here we are applying that another supply sources for stator as well as rotor. So that's why it is called as double excited system. So why synchronous machine needs double excited system means, so actually which motor, when motor is called as synchronous motor means when the motion is running as a rated speed, then it is called as synchronous machine. If it is rotating below the rated speed, then it is called as induction machine, asynchronous machine. Okay, now, so if you want to make the rotor with a stator speed, it requires the double excitation. That's why synchronous machine is belongs to that double excited magnetic system. So easy students, you have the topic, you have the chapter that is synchronous machine. You may get an idea about what is synchronous machine, how it will be operating. Right. So these are the different types of magnetic system. What is single excited and double excited. Now for these two cases, we have to derive that mathematical expressions. It means that how the device will be performing when we are applying that single excited system, as well as how the device will be performing when we are giving that double excited system. So it is like a mathematical equations. Now if you want to simplify these expressions for a single axis system, we need to consider three cases. So I already told you that the three cases are: one is electrical energy, that is we are giving the input, and mechanical energy, that is we are getting the output, and field energy. So while converting electrical to mechanical, in between that field energy is stored. After that only the mechanical energy will get as the output. So that's why we have to derive the equations with respect to these three parameters. One is electrical input energy, magnetically stored energy, and mechanical force. Now these three parameters we are going to derive by considering that one device, that is armature relay. By considering this relay, we can make that what are the equations we can involve in that single axis matching system. So just see this. So this is the device I'm considering for deriving these three equations. One is electrical input energy, magnetic stored energy, and mechanical force. Now this is the example for single axis system. Here it has the two parts. One is fixed part and the other one is moving part. The moving part is called as iron armature, and there is a contact between fixed coil and a moving coil. That point is called as hinge. And so now the fixed part is energized by taking the number of turns with respect to the voltage. Now this part is look like a electrical circuit, right? So electrical circuit in a sense. So this is the circuit we have. So this is the input we are applying here. So this plus minus V, it has the resistance R, and out in a terminal voltage we can get that. So it is VT or IA. So what equation you can get here? What is the equation of the circuit? What is the equation of the circuit? So both of you EC students, you already studied that circuit network analysis, and the triple students you are going to now studying that basic circuits, right? So what is the equation you can get from this equation from the circuit? Okay, let me that. How we can calculate that unknown voltage and current in the circuit? Which laws we can use? What are the laws we can use to find out that current and voltage?
Ohm.
Yeah, tell me. What are the laws we can use to find out unknown value of current and voltage in the circuit? So Ohm's law is a basic formula. So if the circuit consists number of resistors, then what is the law we can use? Number of components.
Ohm's law, sir.
Ohm's law kuda na inga em lewa. There are two more laws are there.
Kirchhoff current law, Kirchhoff voltage law, sir.
Yes, KCL and KVL, Kirchhoff current law and Kirchhoff voltage law. And these two laws use the information regarding that what is the unknown value of voltage and what is the unknown value of current in the circuit, right? Now, if you are using that same law in the circuit, you will get what is the equation means. So here we are giving the input as a voltage, and we are getting that terminal voltage is E, right? Plus additionally there is a losses across the resistor is given by IR. Are clear about this equation? So we are getting that input voltage is equals to output, that is E plus IR. So the drop is occurred across the resistor, and this is the way of finding that equation when the electrical circuit is like this. And what is the and one more thing, what is meaning by lumped parameters or lumped elements? What is the meaning of lumped parameters or lumped elements? So I think you guys have studied, right? Passive elements, active elements, lumped elements, distributed elements. What is the meaning of so what is the meaning of active elements and what are the examples?
So active elements means supplies energy to the circuit, sir.
Can you say examples for this?
Voltage source, current source.
Right. What about passive elements?
Passive elements receives or absorb energy, sir.
Examples?
Resistor, capacitor,
Right.
insulator.
So these are the two elements. One is active and passive. So there are lumped elements. Is there? Have you heard about this word? Lumped elements and winner award. Right. I will tell you that which element is called as lumped elements. Suppose if you take that one circuit, so it's the same thing. So let's consider this circuit. Here I am taking that R is equals to 5 ohms. And now if you want to if you want to arrange this resistance as a 10 ohm, so how we can make? By removing this resistor and by keeping the 10 resistor in the circuit. So it means that which element passive element is easily we can remove the circuit and we can easily insert the circuit. That element is called as lumped element. అంటే ఏ ఎలిమెంట్ అయితే మనం ఈజీగా ఇన్సర్ట్ చేయొచ్చు, రిమూవ్ చేయొచ్చు, దాన్ని లంప్డ్ ఎలిమెంట్ అంటారు. ఓకేనా? దట్ ఈస్ కాల్డ్ as lumped elements or lumped parameters. And distributor అంటే ఏంటంటే it we can't able to remove that parameter. Suppose మీరు ఏదో ఒక మెటల్ తీసుకోండి, ఆ మెటల్ లోపల that metal has that resistance value, but you can't able to change that resistance. So it is naturally occurred in the metal. So that is called as distributed element. Okay na? So that is the difference between lumped element and distributed element. Now in this system we are going to derive the three equations, right? One is equation with respect to the input energy, second one is with respect to the medium, that is energy field, and third one is mechanical force. From this circuit we are going to derive that first equation from this part. So that is completely belong to the electrical energy. And the second part is it is completely, that is the middle part, it is completely belongs to that stored magnetic field. And third one is mechanical force. So from this circuit we are going to derive that three equations, and three derivations may get from that 48 equations. So in 48 equations solve చేసిన తర్వాత then we will get that three equations. Okay? So మీకు ఎటువంటి కన్ఫ్యూజ్ లేకుండా మీకు 48 ఈక్వేషన్స్ ఎలా గుర్తుపెట్టుకుని ఈజీగా చెప్తాను. బట్ you just have to follow my class, right? So this is the initially I am considering the circuit. So if you have paper, then note down this circuit. So I will give 5 minutes time. Just simply then only you can understand that how the derivation will came. So I will give 2-3 minutes. Then draw this circuit diagram. See, after completed, just tell me that. Then we will proceed the derivation. Students, are completed?
Yes, sir.
Right. So now listen carefully. Now we are going to derive the first equation, that is belongs to that electrical input energy. Now, here we are giving the energy is a voltage, that is input. Due to the voltage, the current will be flowing through the circuit, and the circuit makes to generate the flux, that is pi. Now, what is the flux linkage formula? Lambda equals to what is the formula for flux linkage? Lambda equals to n pi, right? So here n is the number of turns, and based on the number of turns, the flux will be generated, and this 2 is called as lambda. Now, after this, we are making there is a presence of induced emf which is available at the output terminal. So, what is the formula for E by Lenz law? What is the equation it was given by the Lenz law? E minus n
N into
T
d phi by d.
right. So it means that according to the Lenz law, the EMF induced at the output terminals, it is always opposes the source. That's why the negative sign is mentioned here. It means that it will oppose the flow of current. See here. So you may know that when the current is flow from the negative to positive, you have to consider that positive sign. So I already told you that in electrical workshop. So when the current is starting from minus to positive, it means that minus means low value. When it is going to minus to positive, it means that it should be increasing. So that's why you have to consider positive value. After that, when we observe here, this is coming from positive to negative. It means that you have to consider the negative value. While look back to the source and terminal, both are opposites to each other. So that's why it is called as back EMF. Back EMF is always opposes the source voltage. Okay. Now, by using these two equations, we are going to derive the equation now. Are you clear about what is the flux linkage? So lambda is the flux linkage. Right. So before formulating that equations, there is some assumptions are needed. So what are the assumptions means? The first one, see, మీరు ఎప్పుడన్నా యాక్చువల్ గా ఏదైనా ఒక అనాలిసిస్ చేయాలంటే ఫస్ట్ దే హ్యావ్ టు నెగ్లెక్ట్ ద లాసెస్. ఓకే, అనాలిసిస్ అంటే రియల్ టైం కాదు, జస్ట్ ఒక ఇమాజినేషన్ గా డిరైవ్ చేయాలంటే ఫస్ట్ ఆఫ్ ఆల్ we have to eliminate the losses. So that's what I'm doing here. The first assumption is the resistance or of the exciting coil అంటే మనకి ఇన్పుట్ సోర్స్ లో రెసిస్టెన్స్ పెట్టాం కదా, of the exciting coil means which coil carries the current, that is called as excitation coil, is assumed to be in lumped from the outside of the coil. Lumped means we can easily remove, we can easily insert and we can easily remove. Thus coil is lossless and ideal. సో ఐడియల్ అనేది దేనంటే ఏ ఎలిమెంట్ అయితే లాసెస్ ని క్రియేట్ చేయదు దాన్ని ఐడియల్ అంటారు. ఓకేనా. నౌ ఐఎమ్ కన్సిడరింగ్ దట్ ఆర్ ఇస్ ద లాస్లెస్. సో ఇక్కడ మనకు losses across the resistor is completely zero. So that is the first assumption. Next one is the leakage flux does not take part in the energy conversion. So actually flux అనేది లీకేజ్ అవుతుంది ఎందుకంటే, సో ఇఫ్ యూ కన్సిడర్ దట్ ఏ మిషన్, సో ఎలక్ట్రికల్ మిషన్ జనరేటర్ కావచ్చు, మోటార్ కావచ్చు, మీరు స్టేటర్ కి సప్లై ఇచ్చినప్పుడు దీనివల్ల ఈ ఎయిర్ గ్యాప్ లో ఫీల్డ్ అనేది జనరేట్ అవుతుంది. ఈ ఎయిర్ గ్యాప్ లో ఫీల్డ్ ఎప్పుడైతే అవుతుందో దెర్ ఇస్ సమ్ లాసెస్ ఇన్ ద ఎయిర్ గ్యాప్. ఆ ఎయిర్ గ్యాప్ లో ఫ్లక్స్ అనేది కొంచెం డ్రాప్ అవుతుంది. బట్ ఇన్ దిస్ కేస్ వీఆర్ నాట్ కన్సిడరింగ్ ద లీకేజ్ ఫ్లక్స్ ఇన్ ద ఎనర్జీ కన్వర్షన్. సో ఇట్ ఈస్ హాస్ టు బి నెగ్లెక్టెడ్. అంటే మనకు రియల్ టైమ్ లో ఏదైతే లాసెస్ వస్తాయో ఆ లాసెస్ అన్ని మనం ఎలిమినేట్ చేయాలి. సో ఎలిమినేట్ చేసిన తర్వాత దెన్ వీ టు గో ఫర్ ద అనాలిసిస్. ఓకేనా. సో దీస్ ఆర్ ద టూ అజంప్షన్స్. One is we are neglecting the losses across the resistor, and next one is we are neglecting that leakage flux. See, the flux linkage was given by this equation lambda equals to n pi, and keep remembering that that is units of flux linkage. So here N is number of tons and pi units is Webers. Okay. So this has to be, we are eliminating. Next, the leakage inductance is negligible and there is no energy losses in the magnetic core. So we all losses, that is 4 losses, we are eliminating this analysis. One is the losses across the resistor we are eliminating, and second one is the flux linkage we are eliminating, and next one is leakage inductance is negligible and there is no energy losses in the magnetic core. And by assuming these 4 parameters, then we can proceed the derivation. So our first derivation part is electrical energy input. So we have the 3 parameters, right? 3 parts. One is input and magnetic field and mechanical force. So first we are going to that. What is the input? Electrical energy. So that has to be, we are deriving now. That is electrical energy input. Now, due to the flux linkage, the reaction EMF E is exists, which is direction is opposite the cause. Suppose this is the circuit we are considering here, and we are given the input is voltage V, and it has the R at the terminal voltage we are obtaining that E, small e, and this EMF volt. So this is called as EMF, and this was given by minus of N d pi by dt, and this voltage, this EMF will be opposite the source. Okay, now, and how we can obtain this equation is by Lenz's law, and this EMF is given by E is equals to d. So E equals to, so instead of N pi, I am substituting lambda here. So actually N into d pi by dt, right? So by replacing N and pi, I am placing just lambda here. So I already told you that the negative sign we are not including in the mathematical calculation. It only shows that how it will be related to the source. So okay now, so negative sign ikkada problematic appudu మీరు యూజ్ చేయకూడదు. సో నెగటివ్ సైన్ ఎందుకు యూజ్ చేస్తారంటే బై ద రిప్రజెంటేషన్, అంటే ఇది సోర్స్ కి అపోజిట్ గా ఉంటుందని చెప్పడానికి మాత్రమే యూజ్ చేస్తారు అన్నమాట. నౌ by applying Kirchhoff voltage law to the circuit, అంటే ఈ సర్క్యూట్ మనకి KVL అప్లై చేస్తే then we are getting the equation like this. So V is the input voltage. So మీకు ఆల్రెడీ చెప్పాను, the energy balance equation is input is equals to output plus losses. ఎందుకంటే no energy will not convert entire fully to the input to the output. There is some losses. Okay now, so that's why input is equals to output plus losses. The same thing, we are giving the input is voltage. Due to the voltage, induced EMF will be available on the terminal circuit, and there is a loss across the IR. Okay now from this equation, so reference, so till now we derive the 3 equations. One is lambda equals to n pi. This is, so you have to note down each and every equation number. Lambda equals to n pi is equation 1, and this is equation 2, and these two are equation 3, 3a and 3b. Okay na, so మీరు ఈక్వేషన్ నెంబర్ ఖచ్చితంగా వేసుకోండి. దెన్ ఓన్లీ యూ కెన్ సబ్స్టిట్యూట్, ఎందుకంటే మధ్యలో సబ్స్టిట్యూట్ చేయడం జరుగుతుంది. సో అప్పుడు మీకు కన్ఫ్యూజ్ కాకుండా ఉంటుంది అన్నమాట. సో దిస్ ఇస్ ద ఈక్వేషన్ we obtained from the KVL applied to the circuit. Now instead of E, that is induced EMF, and substituting d lambda by dt. So this is the voltage equation we derived from the circuit. Now let's move on the next equation. So after that equation, that is V is equals to IR into IR plus, that is instead of E, I am substituting d lambda by dt. So this is the voltage equation. Now I want to know that power equation. What we have to do? We have to multiply that with respect to I on both sides. So if you multiply on both sides with respect to I, then it becomes the power. Power is equals to VI, right? So that's why I want to know that what is the electrical power. So that's why I want to multiply on both sides by with respect to the I. Then you will get VI is equals to I square R plus d lambda by dt into I. Now if you cross multiply this with respect to the dt, you may get this equation. So keep note these equations. VI dt is equals to I square R dt plus I d lambda. Now what this term is indicates, ఈ టర్మ్ దేని ఇండికేట్ చేస్తుంది? సో మీకు లాసెస్ లో చెప్పాను, I square R losses అని. So I square losses అంటే ఏంటంటే when the current is flowing to the resistor more than its capacity, అంటే ఒక రెసిస్టెన్స్ కి కొంచెం కెపాసిటీ ఉంటుంది, అంటే ఆ రెసిస్టర్ కింద ఇంత అమౌంట్ ఆఫ్ కరెంట్ ఫ్లో అవ్వాలి. ఒకవేళ ఎక్కువ ఫ్లో ఏమవుతుందంటే ఆ రెసిస్టర్ బ్రేక్ అవ్వడం కానీ, కాలిపోవడం కానీ, లేదా హీట్ ప్రొడ్యూస్ చేయడం కానీ జరుగుతుంది. If you observe this equation here, the double current is flowing through the resistance and it makes to allow that heat energy losses. అంటే ఆ లాసెస్ అనేది హీట్ ఫామ్ లో వస్తుంది అన్నమాట. సో దట్ ఈస్ ద ఇండికేషన్ ఆఫ్ I square R. సో నౌ ద ఇన్పుట్ పవర్ ఈజ్ ఈక్వల్స్ టు అవుట్పుట్ పవర్ ప్లస్ హీట్ లాసెస్. ఓకేనా. Now if you cross multiply this equation, VI dt equals to I square R dt plus I into d lambda. Now bring the dt terms on both sides. Now you will may get this equation equal to I into d lambda. Now we have the equation V is equals to E plus IR. Now instead of V minus IR you can write E, right? So this is the equation we obtained from the 3a, formula 3a, equation 3a. Then finally we will get E into I dt equals to I d lambda. So reference it is equation 4. So we note చేసుకుంటూ వచ్చేయండమ్మా. Don't skip the equations. So you should have to note that each and every equation. Then only you can understand that. సో మీకు ఒకవేళ అంటే కొంచెం టైం కావాలంటే చెప్పండి. సో ఐ విల్ వెయిట్ ఫర్ వైల్ యు ఆర్ రైటింగ్ ద ఈక్వేషన్స్. So next we move to next slide. So after obtaining the equation 4, from this equation 4, let me see what we have to proceed. Right. So now the input energy to be lossless. Why? Because we are assuming the 4 assumptions right at starting. There is no losses are including here. So it means that the input energy is lossless coil due to that. So we are considering here due to that the current I in the time is dt is given by. So this is the this was the equation we got from the fourth equation, and this is the electrical power. So here power is indicated by W, right? So W ఎందుకు చేస్తామంటే మన పవర్ ని వాట్స్ లో డినోట్ చేస్తారు, ఎందుకంటే W తో డినోట్ చేస్తారు. సో దిస్ ఇస్ ద ఎలక్ట్రికల్ పవర్ ఈక్వేషన్. dWe is equals to E into I theta equals to ID lambda. Here lambda is n pi, and finally we will get dWe is equals to Ni d pi. So Ni d pi you can write that force, that is a force in the sense magnetomotive force. Okay na, the force is was established by the electrical quantity that is called as MMF, magnetomotive force. So here we are going to use two terms, one is EMF and MMF. So EMF MMF difference ఏంటంటే EMF is electromotive force and it is established by voltage or E, and magnetomotive force is established by the current. Okay na. So ఇక్కడ చూడండి, by replacing of Ni అంటే ఇక్కడ కరెంట్ తో ఇన్వాల్వ్ అయింది కాబట్టి, and it is terminated to the MMF and it is denoted by F. Okay na. Now the magnetic system extract that electrical energy from the supply. So ఎప్పుడైతే ఫ్లక్స్ అనేది జనరేట్ అవుతుందో while we apply the voltage and it extract అంటే ఏంటంటే డెలివర్ అన్నమాట. So deliver electrical energy that is generated by dWe is equals to F into d pi. So this is equation 6. So I will ask the formulas in tomorrow class. So what is the equation 6? What is the equation 5? ఎందుకంటే ఇక్కడ మనకు 48 ఈక్వేషన్స్ వస్తాయి. ఈ మొత్తం డెరివేషన్ ఒకే క్లాస్ లో కాదు. సో ఇట్ మేక్ ఇట్ 2-3 క్లాసెస్. ఓకేనా, అందుకని మీరు నోట్ చేసుకొని చెప్తాను. Next. See, so this up to this is the equation that is given by the electrical energy input. Okay now, so up to 6 equations that is belong to that first part. Now we are going to derive that second part, that is magnetic field stored. సో ఇది మీకు రేపు క్లాస్ లో చెప్తాను. జస్ట్ మీకు ఈ సింగిల్ ఎగ్జామ్ సిస్టమ్ డబుల్ ఎగ్జామ్ సిస్టమ్ ఎలా వర్క్ అవుతుందో ఒక వీడియో చూపిస్తాను. Then you can understand that how the this system will be working. Just see this video, then you can understand that how this type of devices will be working based on the input and output. సో మీకు సెకండ్ పార్ట్ థర్డ్ పార్ట్ వచ్చేసి రేపు క్లాస్ లో డిస్కస్ చేసుకుందాం.
This webinar is on singly excited electromechanical energy conversion. This actually is the first topic, important topic, actions of singly excited electromechanical energy conversion system.
So here this is called as solenoid. So I already told you that solenoid is an example for single exit system. Now this is the analog of electrical system. Actually it is not electrical, but for example point of view I am showing here, and here this is the electrical input, and here the magnetic field is stored here, and this is the output. Okay, now just consider these three parameters, then you can convey that information regarding electrical circuit.
The first system that we see here in our animation here that we have is kind of a solenoid valve. So whenever the current flows through this valve, the plunger, the cylindrical plunger that we see over here, it moves, and as the cylindrical plunger moves, the valve in the opening opens and the fluid flows from the inlet to the outlet. As a result of that, we have the flow of the fluid. So this fluid can be anything. It can be water, or it can be fuel for any kind of a combustion engine or anything. So, and once we release the current, so the spring which is being compressed, that expands and pushes the cylindrical plunger back to its original position, and then this closes the valve, and eventually the flow of the fluid stops. So this is a very basic fun. Field is created, and then this magnetic field eventually would.
Students, you can see here it is a linear motion circuit. Here we are applying the coil is mounted on the U-shaped magnet, and when we are applying the current here, the current will be flow here, and due to the current, the flux will be generated. It means that this U-shaped metal acts as a magnet. So when it carries the magnetism, it should be attracted towards. Now, at the same time, when the current is zero, zero, then the coil should be de-energized and its loss is magnetism. Then the linear contact should be moved backward. So this is the called plunger type armature circuit. ఓకేనా. సో ఇక్కడ మనకు వచ్చేసి ఈ మూమెంట్ అనేది లీనియర్ షేప్ లో ఉంటుంది, లీనియర్ పార్ట్ లో ఉంటుంది.
Plunger towards the arm, the static arm, and the spring gets extended. And once we release the current, we switch off the current flowing through the coil, the magnetic field would disappear, and as a result of that, the force attracting the plunger would disappear, and the spring would relax and bring the plunger to its original position. So this is a kind of a simple linear motion. In reality, the mechanisms are a bit more complex, but this is a very simple illustration of those complex linear motion systems that do exist. And as we see here again, it was a singly excited system since we had just one coil. Similarly, we have another system which is also a singly excited system because it has one coil and one source of magnetic field. And here, if we see very carefully, as the current would be turned on through the coil, again the moving plunger would start to move, and in the process it would expand the spring. And as long as the current exists, the magnetic force will keep the plunger in its position. And when we release the current, the spring would come back to its original position and would pull the plunger back. So if we see here, this is again a mechanism which produces linear motion. Similarly, similar to the previous case, as I told you, this is also a singly excited system because we have one coil. And then we have another mechanism which is also a linear motion mechanism, and it is also a singly excited system. So in this case, we do not have exactly linear motion, but an angular kind of movement of the plunger. So as soon as we turn on the current flowing through the coil, the plunger would be pulled towards itself, and it would close to its original position. It will close, and when the current stops to flow, the plunger would come back to its original position with the help of the spring. So this, as we see again, is a motion.
Okay, students, so this is about different types of single axis system. You know, so we did have only one part, that is electrical energy, electrical input energy. Now tomorrow class we are going to discuss about second part is magnetically energy stored. Okay, now so now we can do the class now. So just see that remember these equations, then note down that equation. Thank you. I'm going to end this class now.